Hi everyone. This is our second lesson for geometry. Of course, we had one video where we started. I explained the definition of angle, types of angle, the basic theorems, meaning the adjacent, vertical opposite, notation in geometry. How do we identify? How do we write triangles? How do we write angles? Then this video, I want us to continue from where we stopped in the previous video. Of course, this is the second lesson. All this we are doing is just the introductory part of geometry because there is a lot of confusion with students relating these terminologies. Of course, in mathematics comes with a unique language. Until you understand the words, you understand the language that is being used, then you'll be able to say things are better. Otherwise, then you'll keep finding it difficult to understand um, some aspects of mathematics. All right. So, we want to discuss parallel lines, transversal line, perpendicular lines. Okay. Now, what do we understand about parallel lines? Then perpendicular lines. Then transversal line. Okay. When we talk about parallel lines, the minimum is 2. We don't have a single line as a parallel line. Yeah, parallel lines, we have 2 or more parallel lines. It could be 3, it could be 5, it could be 10. Yeah, most often we discuss 2 parallel lines or 3 parallel lines. All right. So parallel lines can take possibly any direction. It could be this way, it could be this way, it could be this way, it could be this way. Yeah, it could be slanted this way, vertically, horizontally. But the most important thing is parallel lines, even when they do not meet, they have constant distance between them. Now, when you look at the top part of the board and the bottom part, you can see that if you measure from this point to this point, the distance you have is the same as from this point to this point. Is the same distance from this point to this point. Is the same distance from this point to this point. So we can say parallel lines are 2 or more lines that have constant distance between them. Even if you tend to extend them, no matter the length, they will never meet. These are what we mean by parallel lines. Parallel lines are lines that will never meet, no matter how you extend them. A very simple scenario is what? Example is the lines we have in our exercise books, in our notebooks. Of course, we can see they are very straight in such a way that even if you extend them, they will never meet. So parallel lines, they will never meet, even if you extend them. Yeah. So they keep constant distance between them. Now let's make an example of this one. This line and this line. See, the distance from this to this, the distance from this to this is the same as the distance from this to this. Is same as the distance from this to this. So we can say this line and this line, they are parallel. Likewise, this and this, they are parallel. This one and this one, they are parallel, even if you extend them. Okay, so these are what we call parallel lines. Mostly we identify parallel lines in some geometric cases. They will give you 2 or 3 pairs of parallel lines. So what normally we do to identify them easily is by seeing the arrows. See, we use their arrows to direct such lines. So parallel lines are like this. Okay, what do we understand about perpendicular lines? 2 lines can be perpendicular if they form 90 degrees. 2 lines are perpendicular to each other if they meet at right angle. Remember in our previous video, lesson 1, we discussed types of angles. when we discuss right angle as an angle that is exactly 90 degrees. So when two lines meet at 90, we can say they are perpendicular to each other. Okay, lest I forget, parallel lines, this is a symbol for parallel lines. So if we say AB with this symbol CD, we can say AB is parallel to CD. So in notation, we use like this one to represent line. Line AB, let's say here is A, B, C, D. So we can say line AB is parallel. So I don't even need to use the phrase is parallel. So I will only use this line, line AB. I don't need to write the word line. So once I have this one at the top of AB, it means line AB. So line AB is parallel to line CD. So that one is so much interesting in mathematics. Instead of me writing line AB is parallel to line CD, just like this. So when someone understands geometry, the language of geometry, the person sees this one. So it will be interesting to read. Line AB is parallel to line CD. So easy. Yeah, well summarized. Okay, perpendicular lines. This one is a straight line. And here is another straight line. They meet at 90 degrees. Let's call this line XY. And this is PQ. So we can say line XY is perpendicular to line PQ, meaning line XY form 90 degrees with line PQ. So in notation, we say line XY, the symbol for perpendicular is this one. It's perpendicular to line PQ. See? So easy. Line XY is perpendicular to line PQ. So perpendicular lines are lines that meet at 90 degrees, are lines that meet at right angles. Parallel lines are lines that keep constant distance between them and do not meet even if you try to extend them. What do we understand by a transversal line? A transversal line, funny enough, I want to say it interrupts. Now, this is parallel to this. Yeah, this is parallel to this. So when the line comes, it crosses a pair of parallel lines. We call this one a transversal line. Any line that crosses a pair of parallel lines is called a transversal line. And when transversal line crosses a pair of parallel lines, that is when we have different cases of angles as well. So far, this is parallel lines, perpendicular lines, transversal line. All right, the next point, we are done with this. The next point is the angles generated by transversal line. Now, these two are parallel lines. This is parallel to this. And there is a line slanted like this that crosses them. These two are parallel lines, transversal line. Parallel lines, transversal line. Okay. Now let's see here. When we have a pair of two parallel lines crossed by a transversal line, we have 8 angles that are formed. 1, 2, 3, 4, 5, 6, 7, 8. These 8 angles, we have 3 sets of these angles. Now let's say we have here A, B. We have P, we have Q. Let's say we have S, T. We have A, B. So let's say here we have P, Q. Okay, I think I'm done with that. Okay. P, Q, R, S. Now, let me reduce so we can get it better. These are the parallel lines. Here is a transversal line. All right. On the same side of the transversal line, this is above the parallel line, this A. This B again is above the parallel line. Get it well. On the same side, see, look at the transversal line. On the left side of the transversal line, both angles are above the parallel lines. This is above the line, this is above the line. These angles, we call them corresponding angles. We call them corresponding angles. Angles. We call them corresponding angles. Whenever you have a pair of parallel lines and a transversal line crosses them, on the same part of the transversal line, this is above the parallel line. This also above the parallel line. So these angles are called corresponding angles. Mind you, corresponding angles do not only form on what? The left-hand side. It could be on the right-hand side. So likewise, if you have your P, you have your Q. Let's remove this one so that some people do not get it confused. On the same side again, this time around on the right-hand side, on the same side again of the transversal line, this is above and this is above. These are what we call corresponding angles. So you need to be able to identify them when the teacher or the examiner gives a question paper wherein, because one thing about geometry, particularly what angles, you should be able to identify them. You should be able to picture them. So once you see it like this, you know, oh, these are corresponding angles. Why? Because I can see P and Q. They are not only on the right-hand side of the transversal line, both are above. Oh, I can see that A and B, they are not only on the left-hand side of the transversal line, both are above the parallel lines. So again, what is the other format again? They can be down again, below the lines. Let's say here is S, here is T. What is compulsory is that they must be on the same side for corresponding. On the same side, both are below. They are corresponding. On the same sides, both are above. They are corresponding. On the same side, both are below. Like let's say UV. On the same side, both are below. This is below the line, this is below the line. These are corresponding angles. They can be both above, both below. Both above, both below. But they must be on the same side. These are corresponding angles. Now, what the theorem says about corresponding angles, they are always equal. So if your teacher gives a question like this, said, all right, student, find the value of u. You don't even need to write much. Just say, yes, mister, u is equal to 120. So soon, yeah, it's just too easy because u and 180, they are on the same part of the transversal line and both are below the parallel line. So they are corresponding angles. The theorem says corresponding angles are said to be equal. So they are equal. But there is one thing about geometry, even myself, when I started learning geometry, right from level 2, JSS2, Form 2. All right. Um, what I used to find difficult that I had to find time, figure out when to say equal to, when to say sum up to. Okay, that is why in geometry, if you say u is equal to 120, mostly most teachers frown at these answers because it is not only corresponding angles that are equal. We have other theorems who say they are equal. That's why in geometry, it is advisable to be writing the reason. So why do you say u is equal to 120? Say because they are corresponding angles. This is how you abbreviate it, because they are corresponding angles. Because we also have alternate angles that are equal. We also have vertical opposite angles that are equal. So if you say u equals to 120, why is u equals to 120? It could be something else. So you need to write the reason. Okay. Now let's go to another one. In fact, let me use one diagram to explain everything. Now there is another, before I write it, I give you the format first. Let's say here is A, here is B. See, this is easy to put in your head because we can say AB. Yes, they also represent what type of angles, a particular case of angles. Now, how do we identify this? First of all, this is not outside. This is not outside. The two of them are covered within the parallel lines. But one is on the left of the transversal and the other is on the right of the transversal. So these angles, we call them alternate angles. We call them alternate angles. Yeah. When they are within, they are enclosed by the parallel lines, one is on the left and the other is on the right. Remember, one is on the left, the other is on the right. So it could also be this way. Here is S, here is T. The most important thing is they are enclosed by the parallel lines. One is on the left, the other is on the right. So these are also alternate angles. What the theorem says about alternate angles are always equal. So if your teacher gives you a question like this, let's say 138 degrees, they ask you, yes class, this one is it's a classwork, find the value of S. You can say, oh, S and 138, they are enclosed by the parallel lines. One is on the right, the other is on the left. Or I can say S is equal to 138. You saying equal to, are you trying to talk about that this and this, they are corresponding? No. Are you saying they are vertical opposite angles? No. They are what? They are alternate angles. So that is why you are encouraged to what? To be writing the reason, because we don't have one set of angles that we say what they are equal. So S is equal to 138 degrees because they are alternate angles. So try to get the picture very well. Now let's go to the last one. Here, let's say here is T and here is U. Yeah, it is similar to alternate. But the difference is that alternate, one is on the left, the other is on the right. But for this one now, both are on one side. It also looks similar to the corresponding. No, corresponding, if both are above or both are below. But here, they are enclosed by the parallel lines and both are on one side. It could be both are on the left, it could be both are on the right. These are what we call the co-interior angles. Co-interior angles are said to what? Sum up to 180 degrees. So if you have here 60 degrees, the teacher asks you to find U. You can say, oh, I want to find U. What exactly do I do? 60 and U, 1, they are enclosed by the parallel lines. 2, both are on the same side. I can say, oh, they are co-interior angles. Are co-interior angles equal? No, they are what? they sum up to 180 degrees. It's so easy to know that these are not equal because you can see how open this angle is. You see, it is so open. You can see it. This one is like obtuse. This one is like acute. So what do we say? We say U plus 60 is 180 degrees. Why? Because they are co-interior angles. Look the way you abbreviate. So U is 180 degrees. We move this to the other side. Then the rest is easy. Yeah. So these are co-interior angles. So these are what? Corresponding. These are what? Corresponding. See? On the same side, this is above, this above. On the same side, this is below, this is below. On the same side, this is above, this above. On the same side, this is below, this is below. These are what? Corresponding. Okay. Now, they are enclosed. We have this, we have this. Within the parallel lines, on the left, on the right. Or within the parallel lines, on the right, on the left. These are what? These are alternate angles. Here, within the same, this is inside, this is inside. On the same part of the transversal, but both are what? Inside. On the same part of the transversal, both are what? Inside. So try to figure out very well. These are corresponding. On the same side, both are above. These are corresponding. On the same side, both are below. So on the left here, on the right, but they are enclosed. On the right here, on the left, both are within. Yes, on the same side, but within. On the same side, but within. So these are what? Corresponding. These are what? Alternate. And these are co-interior. So try to be able to figure out whenever you see them in the question paper. So the next thing again, we go to the summary points. Okay. Here, it is so easy for us to understand. No matter, okay, now let's see a very interesting case, and it helps a lot. P, Q, R, S, T, U, V, W. If only you can identify the acute angles, the obtuse angles, it helps a lot. Whenever you have two parallel lines crossed by a transversal line, only in a case like this, one, all acutes all acute angles are equal. All acute angles are equal. This is so interesting that R is acute, Q is acute. They are equal. This is so interesting that U is acute. So even when U is located here and R is far off, they are equal because U is acute, Q is acute, R is acute, V is acute. So starting from what? Q, R, Q is equal to R, R is equal to U and equal to V. So all acute angles here, they are equal. So if the examiner gives a question like this, trying to make it so difficult, they give here like 40 degrees. Yes, here like X. Do not hesitate, just say X is equal to 40. But you can see some people are saying, well, let's try to find what should be here. This 40 comes here, we get it, and this they are corresponding. The fact that two parallel lines crossed by a transversal line, all acute angles are the same, all of them are equal. Okay. So the other one says all obtuse angles are also equal. All the obtuse angles here are equal. P is obtuse. It is equal to S obtuse. Also equal to T obtuse. Also equal to W obtuse. So even if you have a question like this, yeah, the examiner tries to make it more difficult. Maybe they give you here like P, they give you here like 130. They ask you to find P. You don't need to say, well, let me move 130 to here to no. Just say P is obtuse. 130 is obtuse. In a situation like this, P is equal to 130. Just so simple. Okay. The third point says acute angle plus obtuse angle is equal to 180 degrees. So this one is obtuse. And they give an acute angle here, which is like, let's say 40. The fact that P is obtuse, 40 here is acute, and they ask you to find P. Just say what? In a situation like this, two parallel lines crossed by a transversal line, any acute angle added to any obtuse angle will give us 180 degrees. So P plus 40 is equal to 180 degrees. Stop going far and saying what? Let me say, well, this one comes to this with this one. This one comes to this. No. Just say, in a situation like this, any obtuse added to any acute will give us 180 degrees. Yeah. So now let's go to the next case. All the transversal line we have been discussing is not perpendicular to it. So what happens if you have parallel lines and you have what? A transversal line that is perpendicular. Well, when the transversal line is perpendicular, forget about the rest. Any angle you see is 90 degrees. This is 90, right angle, all of these ones are 90, all of these ones. So the reason examiners don't bother to give what? A perpendicular line to what? The parallel lines. So this is all what we have for the second video for geometry. The next videos, they will start solving problems. Thank you for watching. Do not forget to like, share, and comment. Bye-bye.